Imagine a line of trucks stretching from the beaches of Normandy to the front lines in Belgium. Thousands of them, roaring down narrow roads day and night, carrying everything from ammunition to canned beans. It was the Red Ball Express, a legendary non-stop logistical operation that sustained the Allied breakout after D-Day. After the Normandy landings, Allied forces advanced faster than anyone had predicted. They broke through German lines and raced across France, liberating towns and pushing the enemy east. But victory came with a problem. The faster the Allies moved, the further they got from their supply depots on the coast. Railroads were destroyed, bridges blown up, and fuel was running low. To keep up the momentum, the Allies created a solution. On August 25, 1944, the Red Ball Express was born. A fleet of over 6,000 trucks, staffed mostly by African-American soldiers, operating around the clock on a dedicated network of roads. Drivers had one job: get supplies to the front, fast. The term Red Ball came from railroad slang for priority express cargo. Special red ball symbols marked the route and the trucks, and no other vehicles were allowed on these roads. Trucks were supposed to be spaced every 60 seconds, but in reality, they often moved in packs, headlights off, in the dark, vulnerable to enemy aircraft and sabotage. The operation's scale was staggering. Between August and November 1944, Red Ball drivers moved over 412,000 tons of supplies, the equivalent of filling 30 football stadiums. They drove through mud, shell craters, and sniper territory, sleeping in their trucks and eating on the move. Mechanics rode along to fix breakdowns in real time. When tires wore out, some drivers stuffed them with straw to keep going. These weren't frontline soldiers, but their role was no less vital. They kept General Patton's tanks rolling, kept the troops fed, and made sure the Allied juggernaut never ran out of steam. Without them, the offensive might have stalled just weeks after D-Day. In the misty jungles and towering peaks of Southeast Asia, two of the most perilous logistical feats of World War II unfolded. Ones that defied terrain, the weather, and enemy fire to keep China in the fight against Japan. These were the Lido Road and the Hump, arteries of survival through some of the harshest terrain on Earth. When Japan overran Burma in 1942, it cut off China's last land-based supply route from the Allied world. The fall of Burma threatened to strangle China's war effort and gave Japan a free hand across much of Asia. But instead of letting China fall, the Allies responded with a pair of insane solutions. One carved into jungle mountains, the other flown through a gauntlet of death. The Burma Road, originally hacked through by hand in the 1930s, was a 717-mile snake, a rough, twisting highway connecting Lashio in Burma to Kunming in China. After the Japanese seized it, the US and British forces began building a replacement, the Lido Road, later renamed the Stilwell Road, through northern Burma's rain-soaked, malaria-ridden jungles. Construction was hell. Workers battled landslides, leeches, monsoons, and disease as they blasted through mountains with pickaxes and dynamite. At its worst, they advanced only a few feet per day, but by early 1945, trucks were finally rolling again, bringing tanks, ammunition, fuel, and food into China to support Chiang Kai-shek's army. The psychological impact was massive. China was not alone, but the road alone wasn't enough. The real miracle was happening in the skies. With no reliable land route, Allied pilots turned to the air. They flew supply runs over the Himalayas, the tallest mountains in the world, in what became known simply as the Hump. Flying from India into southwest China, these C-47 and C-46 cargo planes crossed peaks soaring above 16,000 feet. There was no radar, no maps, no weather forecasts, just freezing winds, violent turbulence, blizzards, and sudden storms that could send a fully loaded aircraft crashing into oblivion. Pilots called it Aluminum Alley for all the wreckage littering the mountainsides. Engine failure meant death. Icing, hypoxia, and disorientation were constant threats. Yet they flew, day after day, often without rest, delivering tens of thousands of tons of supplies. By war's end, the Hump pilots had flown more than 650,000 tons of cargo into China, losing over 1,000 men and 600 planes in the process. It was the first sustained, long-range aerial supply mission in history, a precursor to the Berlin airlift, but in far worse conditions. When the Allies stormed the beaches of Normandy on D-Day, June 6, 1944, they had a huge problem. There were no functioning ports to bring in reinforcements, tanks, supplies, or heavy machinery. The Germans had fortified the main ports and destroyed many facilities. Without access to harbors, the invasion could stall. So, the Allies did something that had never been attempted before. They built 2 entire artificial harbors from scratch, and then towed them across the English Channel. This engineering marvel was codenamed Mulberry. It consisted of hundreds of prefabricated parts, massive floating roadways, piers, breakwaters, and caissons, huge concrete blocks. These were secretly assembled along the southern coast of England, and in the days following D-Day, over 600,000 tons of material was floated or sunk into place off the beaches of Normandy. 2 Mulberry harbors were constructed, Mulberry A at Omaha Beach, American sector, and Mulberry B at Gold Beach, British sector. The harbors included Phoenix caissons, some the size of buildings, sunk to form a breakwater, gooseberries, scuttled old ships used to reduce wave action, whale roadways, floating bridges made of steel that could rise and fall with the tide, spuds, pier heads mounted on adjustable legs to load and unload cargo, even in rough seas. Within days, Allied forces were offloading trucks, tanks, and troops with assembly line efficiency. At its peak, Mulberry B handled over 7,000 tons of cargo per day, but just 2 weeks after D-Day, a brutal storm battered the coast. Mulberry A, American, was destroyed. Mulberry B, British, however, survived due to better placement and rapid engineering adjustments. It continued operating for over 4 months, long enough for the Allies to capture the port of Antwerp and redirect supply efforts. The Mulberries were a testament to Allied ingenuity, planning, and engineering foresight. Without them, sustaining the invasion would have been near impossible. Between 1941 and 1945, Allied ships braved treacherous waters, sub-zero temperatures, and relentless attacks to deliver essential war material to the Soviet Union, keeping Stalin's Eastern Front supplied during some of the most pivotal moments of the war. Ships departed from ports in the United Kingdom, Iceland, and North America, bound for Murmansk and Arkhangelsk. Their cargo, tanks, trucks, ammunition, aircraft, food, fuel, and raw materials. Their escort, often thin, their enemies, U-boats, Luftwaffe bombers, battleships, pack ice, and the Arctic itself. The conditions defied comprehension. Temperatures regularly dropped to minus 40 degrees Celsius, turning steel brittle and rendering anti-aircraft guns useless as crews' fingers froze to the triggers. Ice needed to be constantly chipped off decks to prevent ships from capsizing due to the sheer weight. Many ships were lost, 85 merchant vessels and 16 Royal Navy warships, yet more than 1,400 merchant ships made the perilous journey. It was a gamble with each voyage. Perhaps the most infamous was convoy PQ-17. After erroneous orders to scatter amidst fears of the German battleship Tirpitz, the convoy became easy prey. 24 of the 35 merchant ships were sunk, but the convoys continued. The Soviet war machine, locked in a death struggle against Nazi Germany, could not afford to be cut off. The scale was staggering. Over 4 million tons of supplies were shipped. At its height, convoys involved dozens of vessels, coordinating across thousands of miles of frozen ocean, sometimes under 24-hour daylight, other times in pitch-black Arctic night. This was logistical warfare at its most courageous. Churchill himself called it the worst journey in the world. In June 1941, the Nazis launched Operation Barbarossa, aka the largest military operation in human history. One of the first casualties of that blitzkrieg was the rail network, the ones that kept the vast Soviet landmass connected and mobile. Tracks were torn up, bridges blown sky high, and locomotives sabotaged or seized. The Germans believed that if they could paralyze Soviet logistics, they'd crush Soviet resistance. What they didn't anticipate was how swiftly and ruthlessly the Soviets would strike back on the tracks. At the heart of the Soviet counteroffensive was one of the greatest logistical transformations in military history. Between 1941 and 1945, the USSR rebuilt over 75,000 miles of track, often laying down rail lines at breakneck speed under enemy fire and in terrain that was either frozen solid or swamped in mud. The sheer determination of Soviet railway troops and civilian workers turned logistics into a weapon of war. The scale of this operation was staggering. The Soviets deployed over 600,000 railway workers and established entire mobile repair brigades capable of reconstructing shattered rail lines within hours of liberation. They operated in shifts around the clock, using floodlights at night and laying rails under artillery fire. One battalion could reportedly lay down a kilometer of track in a single day, sometimes even more. But this wasn't just about rebuilding. The Soviets also had to convert the rail gauge. German trains ran on standard gauge tracks, 14 35 millimeters, while the Soviets used broad gauge, 15-20 millimeters. Every mile of reclaimed territory required a rapid regauging operation, ripping up German tracks and replacing them with Soviet ones so that supply trains could follow behind the Red Army. To maintain momentum during offensives like Operation Bagration, the Soviets engineered mobile depots and fuel trains that traveled almost in lockstep with the front lines. Fuel, ammunition, and reinforcements were funneled deep into contested zones via freshly relayed tracks. In some instances, tanks were rolled straight off flat cars into combat. And then there were the factories on wheels, train-based workshops that repaired damaged tanks, trucks, and artillery on the go. Entire train convoys acted as mobile field hospitals, logistical command centers, and even kitchens feeding frontline troops. This relentless rail surge was both a technical and psychological feat. Soviet troops began to equate the sound of distant trains with the promise of fresh ammo, hot meals, and the knowledge that the motherland's might was still behind them. The Nazi high command, once so confident in their initial gains, began to realize that the USSR was rebuilding itself faster than Germany could break it. Railways, once torn up and left for dead, became the backbone of a war machine that would push all the way to Berlin. As Allied forces surged eastward toward Germany's heartland in 1944, they encountered a menacing obstacle that had haunted military planners for years. The Siegfried Line, a fortified belt of bunkers, pillboxes, anti-tank traps, and barbed wire stretching more than 390 miles along Germany's western border. Known to the Germans as the West Wall, it was a psychological barrier designed to discourage invasion. It bristled with concrete dragon's teeth, heavily fortified bunkers with overlapping fields of fire, and dense minefields that made every step forward deadly. To breach this modern-day medieval wall required more than brute force. It required meticulous logistics and engineering precision. Enter Operation Grenade, the southern arm of a pincer movement coordinated with Operation Veritable in the north. But before the offensive could begin, the Allies faced a massive obstacle: the flooding of the Ruhr River, caused by German forces who released upstream dams to buy time. The Ruhr's swelling waters turned the valley into a temporary lake. Entire towns were submerged, roads disappeared underwater, and the already difficult terrain became a logistical nightmare. Supply lines had to be reconfigured, bridge building equipment repositioned, and soldiers waited in damp, freezing conditions for the green light. The pause lasted 2 grueling weeks, and when the river finally receded, the offensive launched with astonishing scale. Thousands of trucks, tanks, bulldozers, and bridging units were mobilized. Combat engineers worked around the clock to clear mines, build pontoon bridges under fire, and lay down temporary roads using steel matting. Despite the German defenses, the Allies punched through the Siegfried Line in several key areas, using a mixture of concentrated artillery barrages, coordinated air support, and relentless ground assaults. And as the Allies poured into the German heartland beyond, it became clear the concrete spine of Nazi Germany had finally cracked. By the time Allied boots hit the beaches of Normandy in June 1944, a new battle had already begun, one fought with valves, pressure gauges, and underwater pipe. The success of the entire European campaign hinged on an invisible artery of fuel stretching beneath the English Channel, Operation PLUTO, short for Pipelines Under the Ocean. When planners in Churchill's war cabinet asked how they would supply the vast quantities of fuel needed by a mobile invasion force in France, one thing was certain: tankers couldn't get the job done alone. They were too slow, too vulnerable to Luftwaffe air raids and U-boat attacks. What the Allies needed was a permanent, secure, and invisible supply line. The answer: a series of flexible oil pipelines laid under the sea from Britain to France, a technological and logistical marvel with no precedent in warfare. It was the most ambitious fueling project in military history. Laying a pipeline underwater wasn't new. What was new was the scale and the conditions. The channel was rough, the distances were long, and no one had ever tried to push pressurized fuel through this much piping underwater at this speed. Two pipeline designs were developed: the HAIS pipe, which used a lead core surrounded by layers of steel tape, jute, and bitumen, and the HAML pipe made from mild steel. But the engineering challenge was brutal. These pipelines needed to be flexible enough to coil, yet durable enough to survive being unwinded from converted ships. Like the London, a modified cable-laying vessel that became known as the HMS Conundrum due to its massive floating drum. Each conundrum weighed over 1,000 tons and carried nearly 30 miles of pipeline. To test the concept, engineers laid a trial pipeline across the River Medway. The pressure systems worked. The next test crossed the Bristol Channel. It too succeeded, but the English Channel was another beast entirely. By mid-1944, pipelines were being laid from Shanklin on the Isle of Wight to Cherbourg, and later from Dungeness to Boulogne. The scale of the project was staggering. Over 500,000 tons of refined petroleum flowed through Pluto pipelines by VE Day. At its peak, Operation Pluto delivered over 1 million gallons of fuel per day to Allied forces advancing across Europe. The total length of pipelines installed under the channel was over 500 miles. They were also burying pipe across Britain in secret routes to prevent sabotage, disguising pump houses as ice cream parlors and seaside cottages. Pluto may have been one of the most decisive contributors to the Allied victory in Europe. Without fuel, Patton's tanks would never have crossed France. Without kerosene, Allied aircraft would have been grounded. Without diesel, supply trucks would have stopped cold. It's no wonder General Eisenhower later called the Allies' ability to keep their armies supplied with fuel the key to victory. By late 1941, Singapore was considered an impregnable bastion of British power in Asia, the Gibraltar of the East. But the British planners had made a fatal assumption that the Japanese could only attack from the sea. The dense jungles of the Malayan Peninsula to the north were believed to be impenetrable. No mechanized force, it was thought, could move quickly through such terrain. The Japanese military, however, had no intention of playing by British rules. Instead, they brought a secret weapon: bikes. The Japanese 25th Army, under the brilliant and ruthless General Tomoyuki Yamashita, landed in northern Malaya on December 8, 1941, just hours after Pearl Harbor. His force of 60,000 men faced a combined British, Indian, and Australian force nearly equal in size. But the Japanese had two advantages: air superiority and bicycles. Rather than rely on trucks that would struggle with mud, jungle trails, and narrow roads, Japanese troops looted bicycles from local populations and used military-issued bikes outfitted for speed. It was low-tech but devastatingly effective. The soldiers could move silently, far faster than infantry on foot, up to 100 kilometers a day, and with almost no need for fuel or spare parts. The Japanese strategy was simple: move fast, hit hard, and never stop. They bypassed strongholds, cut off supply lines, and forced Allied troops into a constant retreat. Bicycles gave them mobility through backroads, rubber plantations, and narrow jungle paths. They made it nearly impossible for the Allies to mount a fixed defense. Bridges blown up by retreating British engineers, the Japanese used inflatable boats or simply carried their bikes across. Washed out roads, they rerouted through plantations. Their engineers laid pontoon bridges overnight. Their infantry was lean, ruthless, and battle-tested from campaigns in China. At the same time, Japanese air units hammered British airfields, eliminating any hope of counterattack from the skies. This was jungle warfare reimagined. In just 55 days, the Japanese swept down the entire Malayan Peninsula, covering over 600 miles of thick jungle and hilly terrain. Town after town fell. Allied morale crumbled. British commanders were paralyzed by poor communication and an inability to adapt to mobile warfare. On February 15, 1942, after just 70 days of fighting, Singapore fell. Over 80,000 British, Indian, and Australian troops surrendered. Churchill would call it the worst disaster and largest capitulation in British history. Operation Bicycle Blitzkrieg proved that adaptability and innovation could trump raw firepower. It was a lesson in mobility, logistics, and the dangers of underestimating your enemy. In the deserts of New Mexico and the laboratories of Los Alamos, the Manhattan Project was racing to split the atom before the Nazis. But beneath the surface of this hyper-secret scientific crusade was a lesser-known story, a desperate scramble to secure one of the rarest resources on Earth, high-grade uranium, and it was buried deep in the heart of the Belgian Congo. At the start of World War II, uranium was not widely understood, but in a quiet corner of Central Africa, at a place called Shinkolobwe, Belgian geologists had discovered uranium ore of almost mythic potency. While most ores in the world contain less than 1% uranium, Shinkolobwe's ore ran as high as 65 to 75% purity. In terms of atomic energy potential, it was a gold mine among gravel pits. It was irreplaceable. There was nowhere else on Earth producing uranium this pure, at this scale. And in 1942, as the United States accelerated the Manhattan Project, it became clear whoever controlled the uranium at Shinkolobwe controlled the key to the atom bomb. The Shinkolobwe mine had been officially closed before the war, deemed too remote and costly. But now, under pressure from the U.S. government and the American Office of Strategic Services OSS, precursor to the CIA, teamed up with Belgian colonial officials to secretly reopen the mine. The terrain was remote and malaria-ridden, the infrastructure was minimal, but security was airtight. American intelligence officers worked alongside Belgian colonial agents to secure, mine, and transport thousands of tons of ore without attracting global attention. All of it was handled through a shadowy corporate middleman, Union Minière du Haut-Katanga, a Belgian mining conglomerate with deep colonial ties. Its director, Edgar Sengier, has secretly shipped over 1,200 tons of uranium to a warehouse in Staten Island before the U.S. even entered the war, a move that would later prove invaluable to the nuclear bomb's momentum. Once extracted, the uranium had to be transported over 1,000 miles by rail and river, from the Congolese jungle to the port of Matadi on the Atlantic. From there, it was shipped covertly to the U.S., often hidden in barrels labeled as mineral concentrates or innocuous cargo. At every step, intelligence officers monitored the route. The risk of sabotage by Axis agents was very real. In fact, one German submarine was reportedly dispatched to intercept uranium shipments in the Atlantic, though none were successfully targeted. The entire Manhattan Project, from the equations at Los Alamos to the Trinity test, depended on this. Without the uranium from Shinkolobwe, there would have been no bomb. While the names Oppenheimer, Groves, and Fermi are etched into the history of the atomic bomb, the Congolese miners who labored under brutal colonial conditions are rarely mentioned. Most worked without knowing what they were digging for. Few were paid fair wages, and none could have imagined that their toil beneath the equator would lead to the destruction of Hiroshima and Nagasaki. By early 1945, Nazi Germany was dying. The Red Army had shattered the Eastern Front. Cities like Königsberg and Danzig were collapsing under Soviet artillery. The Wehrmacht was in full retreat, and behind the front lines, millions of terrified civilians, women, children, the elderly, were trapped, caught between the remnants of Hitler's army and the vengeful storm of Stalin's. What followed was the largest seaborne evacuation in history, dwarfing even Dunkirk. Its name was Operation Hannibal. As Soviet forces surged west, tales of mass rapes, looting, executions, and scorched earth revenge from East Prussia and Poland spread like wildfire. German civilians began fleeing in carts, on foot, and by any means necessary, but snow-choked roads were impassable. Soviet tanks moved faster than refugees. The only hope was the Baltic Sea. Germany's Kriegsmarine scrambled to launch an all-out evacuation. The plan? Use every available ship, warships, merchant vessels, fishing boats, ferries, hospital ships, to evacuate soldiers and civilians from Courland, East Prussia, and Pomerania to German ports like Kiel and Lübeck. It was a logistical gamble on an unimaginable scale. The operation began in January 1945. Over 1,000 vessels were mobilized. Over 2 million people were evacuated across the frigid Baltic. They sailed through Soviet submarines, air raids, and minefields in the dead of winter. Operation Hannibal saved millions, but it came at a terrible cost. 3 of the greatest maritime disasters in history happened during this evacuation. Wilhelm Gustloff, a former luxury liner turned refugee ship, overloaded with 10,000 people, mostly civilians, torpedoed by a Soviet submarine on January 30th, 1945. Over 9,000 died, 6 times more than the Titanic. General von Steuben, torpedoed a week later. Over 4,000 deaths. Goya, torpedoed in April 1945. Over 7,000 killed. Despite total chaos, the German Navy executed the operation with astonishing efficiency. Ships were loaded under artillery fire, ports were bombed, icebreakers cleared frozen harbors, and naval commanders often disobeyed orders to make more room for civilians over troops. Hospital ships treated the wounded mid-crossing, destroyers shielded refugee convoys from Soviet submarines. Many captains defied the Kriegsmarine hierarchy to rescue as many women and children as possible. When it ended in May 1945, Operation Hannibal had evacuated over 2 million people in just 4 months, nearly 10 times the number rescued at Dunkirk. It was the largest evacuation in maritime history, a logistical feat pulled off under the weight of national collapse, moral ruin, and impending defeat.